Hello, today we're going to examine one-dimensional arrays and sorting data in one-dimensional arrays. We're going to start with an open canvas, and the first thing we need to do is declare the array, but not necessarily the size of the array. Let's call this array A1, and we will make it a double precision array. We're going to need some integers, so I'm going to declare a few of those. And the first thing we want to do is populate the array with some numbers. But how many numbers? Well, let's arbitrarily work with 10 elements in the array. The first thing we need to do is redimension the array to handle this. So we use the redim statement. Notice that the redim statement does not need to know the type, because that has already been handled in the declaration. All it needs to know is what is the variable you want to redimension and what is the target size. So now we have a one-dimensional array. Let's fill it with some random numbers from 1 to 10. Actually, we can be even more general and just say n, so that we can then change the size at will. We use a standard assignment statement, and in the parentheses we place the subscript I, which designates which of the elements we are assigning. And let's just use random numbers. So now we have our for loop assigning random numbers. Remember that the random number goes from 0 to 1. So now let's print out what we have. We can print elements of an array quite easily by using the print statement. And just for practice, I will use a format statement. Let's format 8 spaces with 5 values to the right of the decimal point. So let's see what we have so far. Okay, here are our values. They range from 0.11883 all the way up to 0.94045, but they're not in order. So how do we go about sorting these? Well, let's write a very simple sorting program. And I'm going to show you what is known as a brute force sort, which simply uses 2 loops. The first loop goes from 1 to 1 less than the final value, and the second loop goes from the first counter, I plus 1, to the final value, and it checks to see if the lower subscripted value is greater than the second subscripted value, and if so, it does a simple swap. In order to swap, we need another variable. Let's call it a save. So we set a save equal to a sub 1 I. We set a sub 1 I equal to a sub 1 j. And now we need to give a value to a sub 1 j, and that is the value we saved. This is very much a brute force sort. It is not efficient, but it is the easiest sort to understand. Let's run it and see what we get. So I'm going to copy the print statement, and I'm going to say print before and print after. Let's run this and see what we get. Let's make a little extra room here. And let's actually, so things are clear, let's clear text output in this panel. So there we have before and after. Notice that we're going from low to high. What if we want to go from high to low? It is as simple as changing this statement. Now we go from high to low. So that is a simple sort. Now, is there a faster way to do this? There certainly is. And in fact, MathScriptor and Xojo, the extended basic language that MathScriptor is based on, has an internal function called sort. Let's explore using that. And it'll teach us something interesting about arrays in the process. All we have to do, let's comment out this section here. We may want to come back to it. And let's sort using the internal function, which is an extension. Let's run it and see what we get. Well, the internal function sorts from low to high, and it does it extremely fast. That's very nice. But let's examine the zeroth array element. When you declare an array, all one-dimensional arrays and all two-dimensional arrays have zeroth elements. It's easy to forget that, especially if you like to think in terms of one-based arrays. So let's see what is in that zeroth value. Well, when it is declared, it will default to a value of 0. So everything is working quite nicely here. But that's simply a matter of luck. What would happen if we assigned the zeroth element and printed it out and then did a sort and took a look at values 1 through n? What would happen is that we would have now 11 elements, but we're only printing out values from 1 to n, and this is a common problem. If you forget that that zeroth element is there and you do a sort, you may luck out, but what if you do a sort of random numbers, not from 0 to 1, but from -1 to 1? Let me show you how we could do that. And let's ignore again that 0th element and run it. Here's what we have. We have assigned from 1 to n, but we have not assigned the 0th value, and it shows up after sorting. Notice this number here. That 0 comes from a sub 1, 0. And you need to remember whenever you're sorting a one-dimensional array that that 0th element exists. That is one of the most common errors students make. And it is perhaps best that you always do all of your assignments and your prints from 0 to n, noting that that sort operation is going to include the 0th element. Now everything works perfectly. Okay, that's it for sorting and one-dimensional arrays. See you next time.